NFPA 79, Electrical Standard for Industrial Machinery, Section 5.54.22 states that where conduit or tubing is installed through an enclosure wall, a standard pipe, thread hub or knockout shall be provided and shall be securely fastened to the enclosure wall. NEC Article 314, Cable Trays 314.18c requires that where cables or raceways enter or leave cable trays, all openings shall be smoothly rounded and shall be protected against abrasion of the insulation. The intent of these code requirements is to prevent sharp edges from damaging the insulation of wires and cables. While the knockout openings may not technically be conduit openings, they still create a potential hazard to the wires. The assembly team should install bushings or grommets around the knockout openings to protect the wires from the sharp edges. This will bring the installation into compliance with both NFPA 79 and the NEC. IEE Standard 1100-2019 IEE Standard for power and grounding of electronic equipment also includes requirements for protecting wires from sharp edges. When installing electrical wiring within enclosures, it's crucial to ensure that the insulation of the wires is adequately protected from any sharp edges or abrasive surfaces. This is typically achieved by using appropriate bushings, grommets, or other protective devices at all points where wires enter or exit an enclosure through a knockout or other opening. The reason for this requirement is to prevent damage to the wire insulation, which could lead to short circuits, ground faults, or other electrical hazards. Over time, vibration, movement, or temperature changes can cause the insulation to rub against the sharp edge of the opening, gradually wearing it away. This can expose the bare conductor, creating a dangerous situation. Several codes and standards address this issue, including the National Electrical Code, or NEC, and NFPA 79, the Electrical Standard for Industrial Machinery. These codes provide specific requirements for protecting wires and cables from abrasion, and they often reference the use of listed or approved bushings and grommets. For example, the NEC may require that all unused openings in enclosures be closed with suitable plugs or covers, and that any openings used for wiring be fitted with bushings or grommets designed to protect the conductors from abrasion. Similarly, NFPA 79 may require that all wires and cables be supported and protected from physical damage, and that any openings in enclosures be fitted with appropriate bushings or grommets. The specific requirements will vary depending on the application and the type of wiring being used, but the underlying principle remains the same: protect the wire insulation from damage. There are several different types of bushings and grommets available for use in electrical enclosures. Some are made of plastic, while others are made of metal. Some are designed to snap into place, while others are threaded and screwed into the opening. The choice of bushing or grommet will depend on the size and shape of the opening, the type of wiring being used, and the specific requirements of the installation. When selecting a bushing or grommet, it's important to choose one that is listed or approved for the intended use. This ensures that it has been tested and found to meet the applicable safety standards. It's also important to install the bushing or grommet correctly, following the manufacturer's instructions. This will help to ensure that it provides adequate protection for the wire insulation. In addition to using bushings and grommets, there are other steps that can be taken to protect wires from abrasion. For example, wires can be routed away from sharp edges or corners. They can also be supported with cable ties or other fasteners to prevent them from moving around and rubbing against the enclosure. In some cases, it may be necessary to use a flexible conduit or other type of raceway to protect the wires from physical damage. Ultimately, the goal is to create an electrical installation that is safe, reliable, and compliant with all applicable codes and standards. By taking the necessary steps to protect wires from abrasion, you can help to ensure that the installation will provide years of trouble-free service. In summary, firstly, always use appropriate bushings, grommets, or other protective devices at all points where wires enter or exit an enclosure. Secondly, choose bushings and grommets that are listed or approved for the intended use. Thirdly, install bushings and grommets correctly, following the manufacturer's instructions. Fourthly, route wires away from sharp edges or corners. Fifthly, support wires with cable ties or other fasteners to prevent them from moving around and rubbing against the enclosure. Sixthly, consider using a flexible conduit or other type of raceway to protect the wires from physical damage. By following these guidelines, you can help to ensure that your electrical installations are safe and compliant. Now let's examine specific code references and their implications for practical applications. The NEC, specifically Article 314, addresses junction boxes, pull boxes, and conduit bodies. Within this article, various sections cover the proper installation and use of these enclosures. When wires enter an enclosure, they must be protected from abrasion, as previously discussed. This often involves using approved fittings such as connectors, bushings, or grommets to ensure a smooth transition and prevent sharp edges from damaging the insulation. Furthermore, the NEC mandates that unused openings in enclosures must be closed. This is to prevent the entry of dust, moisture, or other contaminants that could compromise the integrity of the electrical system. The specific requirements for closing these openings may vary depending on the environment and the type of enclosure, but generally listed or approved plugs, covers, or sealing compounds are used. NFPA 79, the electrical standard for industrial machinery, provides additional guidance on the installation and protection of electrical wiring in industrial equipment. This standard covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and control circuits. One key aspect of NFPA 79 is its emphasis on safety and reliability in industrial environments. The standard requires that all electrical equipment be designed and installed in a manner that minimizes the risk of electrical shock, fire, and other hazards. This includes the proper selection and installation of wiring, enclosures, and protective devices. In addition to the NEC and NFPA 79, other industry standards and best practices may also apply to the installation of electrical wiring in enclosures. For example, the IEE, or Institute of Electrical and Electronics Engineers, publishes numerous standards related to electrical safety and design. These standards may provide more detailed guidance on specific topics, such as grounding, bonding, and surge protection. It's important to note that code requirements and industry standards are constantly evolving. Therefore, it's essential to stay up to date on the latest changes and revisions to ensure that your electrical installations are always in compliance. This may involve attending training courses, reading industry publications, or consulting with qualified electrical professionals. One of the key challenges in electrical installations is dealing with different types of wiring and cabling. Each type of wiring has its own unique characteristics and requirements, and it's important to select the appropriate wiring for the application. For example, some types of wiring are better suited for high-temperature environments, while others are more resistant to moisture or chemicals. Similarly, some types of cabling are designed for specific purposes, such as data transmission or power distribution. When selecting wiring or cabling, it's important to consider the ampacity voltage rating and environmental conditions of the installation. The ampacity refers to the maximum current that the wiring can safely carry, while the voltage rating indicates the maximum voltage that the wiring can withstand. The environmental conditions include factors such as temperature, humidity, and exposure to corrosive substances. In addition to selecting the appropriate wiring, it's also important to install it correctly. This includes using the proper tools and techniques, as well as following all applicable code requirements and industry standards. For example, when terminating wiring in an enclosure, it's important to use the correct type of connector and to ensure that the connection is tight and secure. Similarly, when routing wiring through an enclosure, it's important to avoid sharp bends and to protect the wiring from abrasion. Grounding and bonding are also critical aspects of electrical installations. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of different metal parts of the electrical system together. The purpose of grounding and bonding is to provide a low impedance path for fault currents, which helps to protect people and equipment from electrical shock and fire. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the location of ground rods, and the methods for bonding different metal parts. It's important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. This helps to prevent damage to equipment and wiring, as well as reducing the risk of electrical fire. The NEC requires that all electrical circuits be protected by overcurrent protection devices, and it specifies the size and type of device that must be used for each circuit. The size of the overcurrent protection device is typically determined by the ampacity of the wiring and the load that the circuit is expected to carry. In addition to circuit breakers and fuses, other types of overcurrent protection devices are also available, such as ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs. GFCIs are designed to protect people from electrical shock by detecting small imbalances in the current flowing through a circuit. RFCIs are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. Electrical inspections are an important part of ensuring the safety and compliance of electrical installations. Electrical inspectors are typically employed by local governments or insurance companies, and they are responsible for verifying that electrical work is performed in accordance with all applicable codes and standards. Electrical inspections typically involve a visual examination of the electrical system as well as testing of certain components in circuits. The inspector will look for any violations of the code, such as improper wiring, damaged equipment, or inadequate grounding. If any violations are found, the inspector will issue a notice of non-compliance, which must be corrected before the electrical system can be approved. In conclusion, protecting wires entering enclosures is a critical aspect of electrical safety and code compliance. By following the guidelines and recommendations outlined in this narration, you can help to ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards. This includes using appropriate bushings and grommets, selecting the correct wiring and cabling, properly grounding and bonding the electrical system, and providing adequate overcurrent protection. By paying attention to these details, you can help to prevent electrical hazards and protect people and property from harm. It's also important to remember that electrical work should only be performed by qualified and experienced professionals. Working with electricity can be dangerous, and it's important to have the knowledge and skills necessary to do the job safely. If you're not comfortable working with electricity, it's best to leave it to the experts. When working with electrical systems, always follow these safety precautions. Firstly, always disconnect the power before working on any electrical equipment. Secondly, use properly insulated tools. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical equipment in wet or damp conditions. Fifthly, if you're not sure how to do something, ask for help from a qualified electrician. The information provided in this narration is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. And be sure to follow all applicable codes and standards to ensure the safety and compliance of your electrical installations.